Alright, welcome. We're starting our third part, the last part of our lecture series on this, and we're going to talk about power and then the two types of current, AC and DC electricity. So that's alternating and direct current. And we won't get too much into AC and DC. We'll talk a little bit about it in class too. Really, you can spend a lot of time just on alternating current electronics, and we can go really in depth on that if we really wanted to and spend months. We just don't have the time, and we're just not going to go there. So when we off with power, so far we've talked about three big quantities. We've talked about current, voltage, and resistance. So current's the flow of electricity, which we measure in amperes. Voltage is that energy behind the electricity that gets it to move, that makes the current, and we measure that in volts. And then resistance is that slowing down of the current that keeps it from getting too fast, and it takes that energy from the voltage and turns it into other things. We measure that in ohms. Now, when you become a homeowner or a renter, or you live in an apartment or whatever it is, and you're on your own, you're going to have to pay your bills. And one of the things you're going to get is an electric bill. And you're going to find that power companies don't charge you by a voltage. They don't charge you by the amperage that you use. They're going to instead charge you by the watt. And really they're going to charge you by something called a kilowatt hour. And we'll get into what that is in a little bit. But they're going to charge you by the power that you use. And they're going to take the power that you use, they're going to multiply it by the time you use it for, and use that to come up with your bill rate. So what is power? Not only that, when you buy appliances, when you buy something in the store, you buy a refrigerator, you buy a light bulb, everything, they tell you how many watts it uses. Like you buy a light bulb, and you can buy an incandescent, old school glass light bulb. Those are typically 60 watts. So that's a regular old glass light bulb. One of those large ones that you probably have in a lamp at home. Looks something like that. 60 watts. If you buy one of the spirally ones with the tubes, oops, those are a little tougher to draw, but I'm going to try. Yeah, that's my drawing. That's not a very good drawing. But those spirally fluorescent tubes, a lot of times those have the same brightness as a 60 watt bulb, but they'll be maybe something more like 30 watts or less. So what is a watt? So we said watts, power. And power is equal to energy divided by time. So it's that rate at which you use energy. So it's a rate. Remember, things that divided by time are rates. How fast are we doing something? So how fast are we burning electricity? And 1 watt equals 1 joule. That's the unit for energy when we talk about kinetic energy, potential energy. And it's 1 joule per every second. So a 60 watt light bulb uses 60 joules of energy each second. So 60W equals 60 joules per second. Now, when we look at power and we talk about what power is, if power is in joules per second, we said that voltage is energy. And one of the things we haven't really talked about, voltage is energy, so it's joules, and it's per amps times seconds. Current's measured in amps. So to get rid of this A on the bottom, if I take a volt and multiply it by an amp, I'm going to get power. So by looking at the units, and what the units really mean. And one of the things that we've talked about before, there are derived units and there are fundamental units. And amps and seconds, those are fundamental units. Joules is a derived unit. When we look at what power is, we can, from looking at the units alone, we can actually get the equation. So you find the power that something uses by taking the voltage and multiplying it by the current. So a 60-watt light bulb is plugged into a 120-volt outlet, and it's going to draw some amount of current. And if I want to find out what that current is, that's pretty easy, right? What times 120 will give me 60? Well, that's 1/2. So the current drawn by a typical household light bulb is 1/2 amp. Alright. So I don't have just one light bulb in my house. I don't have just one refrigerator. Well, I do. I do have just one refrigerator. But I don't have just one refrigerator and that's it. Right? I've got tons of appliances in my house, so I use a lot of power. And you do too. Everybody does. We have all these different things in our houses, and we use all this electricity. So for convenience sake, sometimes we deal with what's called a kilowatt. And maybe you noticed it, and maybe you didn't. But kilowatt is one of our words on the word wall, so it's something important. And a kilowatt is 1,000 watts. Remember we talked about milliamps and amps? Well, one amp is 1,000 milliamps, and here a kilowatt is 1,000 watts, just like a kilogram is equal to 1,000 grams. And a kilometer equals 1,000 meters. So 1 kilowatt equals 1,000 joules every second. And this is worth talking about because when you look at those bills and you get that bill from the power company, a lot of times you're going to be dealing with kilowatts on your bill. Because they're not going to bill you in watts because the numbers are too big, so they're going to convert it to kilowatts. So let's talk a little bit more about your electric bill and how you actually pay for things. So when you look at your bill, they're not going to give it to you in kilowatts. They're going to say you use this many kilowatts because kilowatts are a rate. It's how fast you use the electricity. They really want to charge you for the amount of electricity you use. So if a watt or kilowatt is a joule per second, they're going to instead, they don't want to bill you for the rate. They don't want to bill you for joules per second. No. They want to bill you for the energy you actually use, and that's the joules. So they want to bill you for the energy. So they're going to take your power and they're going to multiply it by the time you use that power, and that's going to give you your energy. So they take your kilowatts, they multiply it by the hours you use it for, and that gives them the kilowatt hour. Kilowatt hour. So a kilowatt hour is what you actually get billed at by the power company. So they're billing you for energy. So 1 kilowatt hour actually works out to be about 3.6 times 10 to the 6th joules. That's a 3 with 1, 2, 3, 4, 5 zeros after it. That's a fair amount of joules that you're talking about being billed at. And different utilities have different rates, but the current rate's about somewhere between 10 and 15 cents a kilowatt hour. So it's not that much. But let's just say it's 15 cents. So they will charge you 0.15 dollars per kilowatt hour, for example. And that's how many, that's where they're going to come up with it. So they're going to charge you that amount of money for every time you use a kilowatt hour. So if I do something like I have a 60 watt light bulb and I leave it on for 100 hours, okay, I have a light bulb out on my porch, for example, that I leave on all the time. Leave it on all night, helps deter crime. So let's just say I leave it on for 100 hours. Well, that means I'm going to use 60 times 100, so throw on 2 more zeros, that's 6,000 watt hours. But I want it in kilowatt hours. So to go from kilowatts to watt, or from watts to kilowatts, I'm just going to divide it by 1,000. So 6,000 divided by 1,000, that's going to be 6 kilowatt hours. And 6 kilowatt hours at 15 cents a kilowatt hour. So what's that? So 15 times 6. 6 times 5 is 30. 6 times 1 is 6, plus 3, 90. So this was 0 point. So that means to leave that 60 watt light bulb on for 100 hours is only going to cost me 90 cents. If my bill rate is this up here. And to find out what your bill rate is, you need to look at your power bill. So you'd have to ask. Or we can check online, and we'll try and do that tomorrow in class. So that way it's up to date with current. Alright. So we only got about 2 minutes left. So here's what we're going to say. We're going to say alternating and direct current for tomorrow in class. But here are the key things to really remember with AC or alternating current. Alternating current changes the direction of the current at regular rates. For example, in the United States, the current in your wall changes directions 60 times each second. And direct current is always in the same direction, no matter what. DC goes one way the whole time. So tomorrow in class we're going to talk about AC current a little bit, and we'll talk about why we use it in homes. And we'll look a little bit at, we've been dealing with DC current all this time in class. I will say one thing. This is from a guy named Tesla. And this one over here is from somebody else named Edison. Alright. So that's about 14 minutes. It's a little longer than I would have liked, but we're there. So we'll stop there and we'll save the rest for next time. Alright. Thank you all, and we'll see you in class.